So hello friends, welcome back, and in this video we are going to see problem 2 of Codechef Cook-Off September Cook-Off. Starting with the problem bulbs and wires. So firstly I will explain the problem statement in brief, although you should read it properly by yourself. So it says that we have n light bulbs. Initially all of these are off. To show the off state I will use 0, and to show the on state I will use 1. And it is also said that these n bulbs are connected by n minus 1 wires. Very fine. Then I can perform some operations so as to reach to a final state S. Now the state S, it is given in the input only, that I need to reach the final state 0 1 0 0 1 from that state of 0 0 0 0 0, which means that I have n bulbs and I need to reach to a final state as shown in the question. Very fine. The operations I can perform is that the number k right here, I can perform at most k number of cuts in the wiring as I showed you above. I have n minus 1 wires, so I can perform at most k cuts on those wires. Very fine. Then the next operation I can do is that I can switch on any bulb I want, and if I switch on any bulb, then it is for sure that the bulb which is the another bulb, suppose if I make a cut right here and right here, right? So if I remove this, so if I switch the bulb right here on, then the bulbs which are wired with the on bulb will also be switched on. So it will also switch on. Like for example, if it had also been connected, then if it is on, so it will also be on, it will also be on. Understanding the fact? Okay. Now the last operation is that I can disconnect some bulbs from the electric network. Here, like what it means that, suppose I have these bulbs on, right? So if I want to make this off now, what I can do is I can completely remove it. Now you might say, Aryan, if I remove the middle one like this, so will all the others will be off? No. Now in the final state, which means in the step 3, if you disconnect any bulb, so no other state will be changed. Only the state of the bulb which you removed will change. So at last I want to know that, okay, at max how many number of bulbs I need to disconnect so as to reach to a final answer S. Now when you think of this problem, then first let's start from scratch. I had these 5 bulbs, right? Let us make them 0 0 0 0 and 0, and as I said that they are connected initially. Now I can clearly see that I need to transform to the state like this. So first thing that if I want to transform to a state like this, which means that I need to perform minimum number of operations. So if I plot it like in the same way, so I have 5 places. I will write it as 0 1 0 0 1, and I will connect them as well. Now from the second point you can easily see that I can switch on any bulb, right? So it is like in my mind that for moving a bulb from 0 to 1, it is very easy for me. But if a bulb is on, so I need to switch it back to 0, which means that I need to perform the operation 3 to make 1 to 0. So now it is in my mind that moving from 0 to 1 is pretty easy. I can do it very easily. I will have no operations in mind. Like I don't need to worry about anything. But if my any bulb is on in on state, so it will worry me. Now when you think about that, so, and you also know that if the bulbs are connected to each other, then if I make one bulb on, so every bulb will be on which are connected to it. So what I will try is that I will pick a bunch of zeros out of these zeros in S. I will pick a bunch of zeros so that I will remove initially, like in the step, see in the step 1 I can make k cuts. So by making the k cuts, at most k cuts, I will remove the bunch of zeros, maximum bunch of zeros, so that what will happen next, that if I see maximum bunch of zero is right here, so I will remove that maximum bunch, so it will become disconnected. Right now I can easily see that I can make it 1, which means that I will remove the bunch of zeros right here. I will remove it, so it will become right here. Now I need to transform this 0 to 1, so I can make it in any step, which means that no cost is required to me, so I will make it 1. Now I also need to make it 1, so what I will do, I will make it 1. Now you will clearly say that, okay Aryan, if I make it 1, so the 0 right here, it will also be 1. Yeah, it is also be 1, right? It is very fine, but actually I wanted it to be 0, so in the last step I need to disconnect it. Now you might wonder that, okay, what if the k right here, if it would have been 3, so what would have happened? So see, if it would have been 3, so I would have made one more cut right here. So what would happen? I used 1, 2 and 3 cuts, so it will be removed. The bunch of zeros here will be removed, and yeah, for sure, now I have remaining the 0 right here and 0 right here, which are already not attached with other zeros, so I can make them 1 very easily from the step 2, which is free of cost. So the first intuition which strikes your mind is that, okay, I need to remove the bunch of zeros along with it, right? Very fine. Now to understand that more better, let's take an example. So let's have an example, although I wrote it, let me write it down. So it is 1 0 0 1 0 0 0 1 0 1. Now you need to reach a final state like this, right? So now for now, let's suppose that my k is something, although afterwards I will put some value so as to analyze it, but for now the problem in my mind is that I need to extract out a bunch of zeros right here, right? Bunch of zeros. Very fine. And I also know that at any stage to extract the bunch of zeros, see, for me it is very like it, I am very, I'm the person who will take maximum bunch of zeros in a go, maximum bunch of zeros. So as to take the bunch of zeros right here, see, maximum bunch of zeros right here are 3, so I will always opt to have the maximum bunch in the first go, right? So I will always try that in minimum cuts how many maximum bunch of zeros I can obtain. So what I will do, I will remove those maximum bunch so that minimum number of zeros need to be transformed back. And what I mean by minimum number of zeros need to transform, see, what will happen was that if I remove the bunch of zeros, now some zeros will remain. Out of those zeros, some zeros need to transform to the 1, and if I transform those to 1, so all will be transformed to 1. So I need to transform 1 back to 0. So I need to make those zeros, which means that if I had my array initially right here, right, if although initially all of these are 0, so if I remove these bunch of zeros, now, okay, I should make like this. So now what will happen is that if by any chance I want to make this 1, so I will make it 1, so it will also automatically become 1. Understanding? So it will also automatically become 1. But now what I need to do is I need to transform these ones to back to 0. So my main aim is to work on zeros rather than ones. Very fine. Let me remove this. Is just a clutter. Okay. So now the fact which you have to realize is that you need to extract maximum bunch of zeros out of it. Very fine. So what I will do, I'm pretty sure that to remove the zeros which are in between, I need to make 2 cuts, one right here, one right here. Very fine. And to extract the bunch right here, I also need to make 2 cuts, one right here, one right here. And to extract the 0, I also need to make 2 cuts. But what if I say that if my problem would have been something like this, right? 1 0 0 0 0 1 0 0 1. So you can clearly see that I have the bunch of zeros right here, bunch of zeros right here, and bunch of zeros right here. To extract the bunch of zeros right here, I need to make only 1 cut. To extract the bunch of zeros right here, I need to make 2 cuts. And to extract a bunch of zeros right here, I need to make 2 cuts. So now my problem is further reduce to that, I will extract a bunch of zeros. Yeah, I'm pretty fine with that. But I need to also maintain that how many zeros are, like how many bunch of zeros are there which needs one cut, and how many bunch of zeros with their bunch size require two cuts. What I mean by that? I mean that I will store, like I will have a vector called rec1. Rec1 means which require one cut, and a vector called rec2. Rec1 will have the size, which means bunch size of zeros which needs one cut, and you can pretty surely see that the rec1 size will be at most, means the vector size, it will be at most 2, because either what can happen, see what can happen is that either I can have 1 0 0 1 0 0 1, which means that no ending zeros right here, or I can have 0 0 1 0 0 1, so I can see that one ending zeros right here, or I can have 0 0 1 0 0 1 0 0, which means two ending zeros right here. So either I can have no ending zeros, which means no ending zeros, or I can have one ending zeros, like in the one end, it may be here, it may be here, like, or it I can say that 1 0 0 1 0 0, which means like here as well, and or I can have like here and here. Okay, so you can clearly see that I can have these conditions for rec1, which means that which require only one cut. Now before like having a rec1, you should also realize one fact, that if the my s string is completely 0, which means that it is completely 0, so I don't need to make any cut. I will remove the whole bunch out. So my number of alterations required, or you can see the number of steps 3 which I need to do are 0. So you need to make a special case for that, that if my whole string is 0, then yeah, for sure that 0 cuts are required. Very fine, we will add it later in our code. Now you need to make your rec1 array, right? So what you will do is basically you will walk through your array from the left, and you will have the 0 count until you encounter any other element. Very fine. And like it is from the left end, right? And if you want to do from the right end, as you can see here, you will move from the right end and you will encounter 0, and if at any step, if you encounter any particular element, suppose 1 or any other element, yeah, it is 1 only, so you will stop. Now you can store in your vector the size of the left part, which means the 3 here, and the size of the right part, which means like here it is nothing, but if it would have been, so it would have been stored right here. Okay, so let us store, suppose 2. Okay, now so as to find the size of this middle part, like which needs 2 cuts, so although like you can have multiple variations of how to find it, but I basically, like what I feel like is I make this array easy to work on, which means that although yeah, I might think that it was hard, like I made it hard bit, but what I use the approach I am sharing with you guys. Although you basically you want to have the bunch size, I don't care how you do it, I just need the answer. So what I did, I will share with you guys. So if I have 0 0 0, so before my before my between my any 1 and 0, I will have -1. So I will have -1 right here. So I have a 1. Then after that, you can clearly see that I again have a 1 and 0, so I will have a -1. Then I will have 0 0 0 0. Then I will have -1. Then I will have a 1. Then I will have again a -1. Then I will have a 0 0. Then again I will have a -1. Then again I will have a 1. Then again I will have a -1, and then I will have, sorry, then I will have a 0 0. Although like it is very vague to use this in my problem, because see I only have zeros and ones, so I can clearly use my 1 to have the 0 count. But if you have more elements, like if you had 0 1 and 2, and if you want to find the 0 count, so you will, like the approach I use -1 to put in between so as to show you the endpoints, it will help you. But yeah, I was in bit hurry, so I used this. But yeah, it is pretty vague, So you can only use your 1 to find out the bunch size. Although I inserted -1 in between, and after that I used my -1 to find the bunch size. Pretty fine. Then what I will do, I will just simply find the bunch size, which means that I will iterate from between two -1s to check the bunch size. Here the bunch size, as you can see, it is 4. Here the bunch size would be 2, and it is the end size which is in rec 1, and it is also the end size which is also in rec 1. Now like if you have 4 and you have 2, now what I will do is that I will just simply sort. Basically I have now my rec 1 and rec 2. Fine, the main thing which I wanted was rec 1 and rec 2. So let me write my rec 1 and rec 2 again. So rec 1 had 3 and 2. So I will sort my rec 1 and rec 2, because see, I need the maximum bunch size, right? So if I will sort it, so I will extract the last element from my vector. So yeah, sorting is for that. Then I had my rec 2, which was 2 and 4, right? So what I will do now, that I will run my loop like while my k is more than 0, right? Then the first thing which I will do, that I will check, okay, which one is more out of these, rec 1 and rec 2. But I also know that to utilize rec 2, I need my k more than 1, because I need to make 2 cuts. So I need at least 2 cuts to be available. So I need my k to be at least 2 or more than 2. Very fine. For my rec 1, I need my k like to be more than 0, which means I need to have at least one cut left. Although I am running my loop, so it is not necessary as such. But yeah, for rec 1, you should point that you need at least 1 cut, and for rec 2 you need at least you need at least 2 cuts. So what I will do, that I will check, okay, out of my rec 1 end, which means the end value of rec 1, if it is more, or if it is more, rec 2 end is more. If my rec 2 end is more and my k is also more than 1, so I will use my k, which means I will reduce my k by 2, which means k minus 2, and I will use this number of zeros, which means that, see, out of all these zeros, which means I have 1 2 3 4 5 6 7 8 9 10 11, so I have zero count as 11. Now I can easily see that what is my 4. My 4 is that with the number of cuts I can remove these zeros. So out of 11, my 4 zeros will be removed. Number of zeros remaining will be 7, which I need to operate on. So with the help of this, like the rec 1 and rec 2, I am reducing my number of zeros which I need to transform in the last. Understanding what I am saying? Transform by meaning. Transform the meaning I showed you here. Where I showed you? Yeah, but transform by meaning I showed you here, that the remaining zeros which were left, I need to transform those back, which means, see, it will be 1, so I need to transform back to 0. So remaining zeros I need to check. Here video is going on pretty fine. So yeah, so what you will do is that you will have this rec 1. So if my k is more than 1, so I will utilize that rec 1 and I will reduce my the 0 count. So actually I firstly have the 0 count as in the variable called this, so it will show 11. So and then after this I use my variable called used, which is indicating my used zeros, how many zero I can use at max. So yeah, with the help of the loop I will check that, okay, if it is more than 2 like 1 and it is more, so I will use this, or if it had been more, so I will reduce my k by 1 and I will add this in my answer called used. And as you can know that once I use it, so I don't need it, so I will just pop it back, or if it is used then I will remove this, and I will do it until my k is exhausted. So it was the logic. Although the logic was not hard to guess, it was easy, but the code was a bit hard to write, I guess. Not hard that much, but yeah, the edge case also was a pretty much thing which you need to take care of. So quickly I will show you the code. Although the video, oh my god, 20 minutes, it's okay. So the code is pretty fine. That firstly you will have n and k, then you will have the string s, then you will have the 0 count right here. Then if, as I said, that if my whole string is 0, then yeah, it will be simply 0, answer would be simply 0. Then I had my vector a, as I showed you that what I had was that, let me show you that what I had was, I made the array like this. I inserted -1 in between, Yeah, although it is not necessary, but yeah, I will show you that. But I'm still saying that it is not necessary because you have only arrays of zeros and ones. But if in case in future, if you had arrays of 0, 1, 2, any number, but still you find the want to find the bunch of suppose zeros only, after in those cases, your the method like -1 inserting or element something like that, it will help you. So yeah, here I just inserted my -1 in between as I showed you. Then I had my array or vector called rec1, which will store the bunch size of zeros at the ends if it is there. Then it is for the first, which means left bunch size, and if it is not 0, then I will insert it in my push back in my rec1 size. Then I found it for the right one, which means that I found for the right part, and if it is not also not 0, then I will push it in my rec1. Then what I had was I had my rec2, which means that which required 2 cuts. Then I also had the same thing. I checked for -1 elements, and between those -1 elements I checked the number of zeros, and I run the loop for those zeros count, and I inserted it in my rec2, so that I will have the bunch size of zeros which require 2 cuts. Then as I said that I will sort my those two, rec1 and rec2, pretty fine. Then I will have my variable called use, which will indicate me that okay, how many bunches of zeros I can remove by making the cuts, so that after removing the maximum number of bunches of zeros, the final thing which remain in my hand will be initial zero count minus the bunch like I used basically. So yeah, I run this loop until my k is more than 0, and if my size is as I said that it should be, I compare basically the elements, last elements, and if it is, then I remove the, like, if at any step I use any element, so I just basically removed it. So yeah, I did the same thing in this. I basically utilized all my bunches, like I used my rec1 and rec2, and I choose the maximum part out of these. So at last I just want to output my zero count minus used. So I hope that it was pretty useful for you guys, although the video has been pretty lengthy. I don't know why, but yeah, I tried my best to explain you. If at any step you had any doubt, then you can write it below, although I assume that I had explained every point, every edge case, and every case which you need to check or see or think. So yeah, that's all for this video, and I hope that you guys have enjoyed it. If yes, then do the like button, and see you guys in the next video. Until then, be happy, keep going. Bye.